Hi. So this is a demo of a RAG based dashboard, which is called RAGnalysis. And what it does is it actually compares the various RAG in terms of how the output looks like. Overall, a comparative analysis of some of the RAGs. So the five RAGs that we have used is, first of all, is the naive RAG, that is the conventional RAG. Then there is HyDE RAG. Then there is CRAG RAG. Sorry, I mean that itself is the RAG. GraphRAG and CrawlRAG. Right. So I'll just start from fresh. So let's say I have there's an annual report. If you want to look at it, let's say it's already open there. So I'll just first upload it here, and this is the annual report. This is by TCS. Is by as on December 31, 2025. This uh, is available on the internet. So yeah, so this is the text. Uh, so let's say we'll try to find something which it might be quite complex. So okay, so first what I'll do is I'll process the document. So it has been uploaded. So the components that has been used here is called LlamaParse. Parse. LlamaParse is used to extract the text, the tables, and the images as a markdown. Then there is like I have used GPT-4o for the document entity extraction. Then for the smart chunking, I have used the standard parent and child chunk in and stored it in ChromaDB as vectors. And for the knowledge graph, I have used Neo4j to visualize the knowledge graph. So that is an interesting aspect. So this is what it is uploading right now. So it will take some time. So if we look at the code, we can see the chunks are being processed. Yeah. So the l- llama chunks parse is being we're working here. These are the entities. Relationship type is this. There are standard 32 chunks. The domain is financial, and knowledge graph is being made. So for that, the extra chunks are being made here. 27, 28, 9, 30, 31, and 32. Yeah. So this is done. Entities are 72. The relations are 25. If you look at here, yes. So the log is being here. The log is being made. And if you want to see the knowledge graph, you can see it here. Yeah. So this is the knowledge graph. It's quite interesting. It looks quite intuitive. And if you look at it, if you zoom inside it, let's say company has issued capital June 12, June 18, preference share. Fresh issue has been issued in August 19. Bonus share, equity share, and like this is the Tata Sons Limited, the promoters to whom shares were allotted. So, and if you want to see it in a list, we can see it here. All the lists are here. And now, if we want to see if we want to chat, so this was the last chat that I used. Let's say I want to see anything. So something very hard to get. So let's say, when was the annual general meeting held? Okay, let me ask, when was the annual general meeting held? And I'll just enter. This will run all the pipelines. I mean, all the rags will run in parallel. And yeah, this is the output. So as you can see, the hide rag is not able to see it, is not able to find it. The crawl rag is also not able to find it. This is the retrieve chunks. So the naive rag is able to find it. The graph rag is able to find it. Yeah. So this is the overall output, and this is the time taken. This is for the latency comparison. The least time is taken by naive rag. The most time is taken by CRAG, CRAG, and successful for some cases. So like this is not an example to show how which is more successful than which. Like I have used other examples where some other rag is giving accurate results. So this is just a comparison. So again, this is the history that we can shape. We can actually see here when was the last annual general meeting held. This what was the section and so on. If we look at the code, the code is actually done in. So I have used Fast API to actually host all the things and to post and pull the request, and the UI is just simple JS, HTML, and CSS. And for all the rags, I've used separate .py files, and this is the orchestrator that will give the overall understanding, and this is the processing of the PDFs into chunks. Yeah, so that's all. Thank you.